Dividing polynomials. It turns out that dividing polynomials is extremely important in the study of polynomial functions. So we begin here with the division algorithm. When dividing a polynomial p of x by another polynomial d of x, we get the polynomial q of x, which represents the quotient polynomial, plus some remainder polynomial r of x divided by the original divisor. Or another way to write it is p of x equals d of x times q of x plus r of x. So again, p of x and d of x are simply the dividend and divisor polynomials. Q of x is the quotient polynomial, and r of x is the remainder. If you find yourself getting confused when looking at division of polynomials, remind yourself how we divide numbers. So here I'll just provide a very simple example. If I want to divide the number 17 by the number 3, we know that we can use long division to accomplish this task. So 3 divides into 17 5 times, and 5 times 3 is 15, and when we subtract here, we get a remainder of 2. So one way to write the answer when dividing 17 by 3 is I can start with the quotient, which in this case is 5, plus the remainder, which is the number 2, and that goes over the divisor, which is 3. So we could say 5 plus 2/3. Or in the case of numbers, we would simply write this 5 and 2/3. But please also realize that we could have said that 17 is equal to 5 times 3 plus 2. So when you look at these representations up above here, we are simply referring to each of the two different ways that we can represent division. So in our first example, we want to divide the polynomial 6x squared minus 26x plus 12 by the polynomial x minus 4. So we begin with writing x minus 4 and then our long division symbol, and then we're dividing that into 6x squared minus 26x plus 12. Now the way this works is we simply focus on the leading term of the divisor and the leading term of the dividend. So let's ask ourselves, how many times does x divide into 6x squared? So we're taking 6x squared and dividing it by x, and this gives us 6x. So we'll put that answer here. So x goes into 6x squared 6x times. And then just as we do with numbers, we are going to multiply 6x times x, which is 6x squared. And we're also going to multiply 6x times negative 4, which is negative 24x. Now remember, in the long division process, the next step is you have to subtract. And when I say subtract, I mean we have to subtract this whole thing here. So when we subtract, it's simply going to change the sign of both of these numbers. And then we combine like terms. So these cancel out. Negative 26x plus 24x is negative 2x. And then the positive 12 will just bring that down. And now we're going to repeat the process. So now we simply ask, how many times does x go into negative 2x? So negative 2x divided by x is negative 2. So I'll write that answer here. And now negative 2 times x is negative 2x. And negative 2 times negative 4 is positive 8. And I'm just going to write 8 instead of positive 8. And the reason I don't put the plus sign is because, remember, the next step is we have to subtract these, which means we're going to change the sign. And this positive 8 simply becomes a negative 8. Now 12 minus 8 is 4. And notice that these cancel out once again. And once your remainder here is a degree that is less than your original divisor, you are finished with the process. So now we just need to translate this into an answer. So the quotient when dividing 6x squared minus 26x plus 12 by x minus 4 is 6x minus 2. Plus, we have a remainder of 4 over our original divisor, which was x minus 4. So this is one way to write the answer. And of course, the other way to write the answer is simply 6x squared minus 26x plus 12 is equal to the divisor multiplied by the quotient, so that's x minus 4, multiplied by 6x minus 2, plus the remainder, which is 4. So both of these are correct. It's just a matter of which way we want to write the answer. Now let's do a problem that is a little bit more difficult. In this case, we're dividing a higher degree polynomial by a higher degree divisor than before. So we are going to take the polynomial 2x squared minus x plus 2, and we're going to divide that into the polynomial 8x to the 4th. Now notice that there is no x cubed here. We're going to write down plus 0x cubed, and then plus 6x squared minus 3x plus 1. It's important to have this term in here as a placeholder. Now let's go through the long division process, which says we take the first term here and we divide it by the first term here. So 8x to the 4th divided by 2x squared. If you do the math here, this is going to be 4x squared, and we'll put that here. Now let's multiply 4x squared times 2x squared, which is 8x to the 4th. Now you should notice that when you're done doing the division and you get this answer here, anytime you multiply this term by this term, you should get exactly what you have here. But remember, we also have to multiply 4x squared times negative x, which is negative 4x cubed, and also 4x squared times positive 2, which is positive 8x squared. And again, when it's positive, I'm just going to leave it blank because we know we have to subtract, which means we have to change all the signs. Now, when you combine like terms, these cancel out. We get 4x cubed here. We get minus 2x squared. And then these two terms we're just going to bring down for future steps. Now we repeat the process. We're going to start with 4x cubed. And we're going to divide that by 2x squared. And this gives us 2x. So that's positive 2x. Now we multiply 2x times 2x squared is 4x cubed. 2x times negative x is negative 2x squared. 2x times positive 2 is positive 4x. And then remember, you have to change the signs. Now in this case, something interesting happens. These cancel out and these also cancel out. So that's kind of a bonus. Negative 3x and negative 4x is negative 7x and then plus 1. Now let's repeat the process. We're going to take negative 7x and divide it by 2x squared. No, we're not going to do this, right? Because again, we're done as soon as the power here is less than the power of the divisor. So in this case, we're finished. And now we're just going to write our answer in the form that they request, which is this form right here. So we're going to say our original polynomial, which is 8x to the 4th plus 6x squared minus 3x plus 1, is equal to the divisor, 2x squared minus x plus 2, multiplied by the quotient, which is 4x squared plus 2x, plus the remainder, which is negative 7x minus 1. And I can write that as minus 7x plus 1. And this is the answer according to how they asked for it. Now, of course, we also could have written the answer as the original polynomial divided by 2x squared minus x plus 2 is equal to the quotient, which was 4x squared plus 2x, plus the remainder, which was negative 7x plus 1, over the divisor. Now again, both of these are correct, but it just depends on how they want you to write the answer. Now let's focus on a method of division called synthetic division. Synthetic division is a way of making long division a much easier process. Suppose we want to divide the polynomial 2x cubed minus 7x squared plus 5 by x minus 3. One way to do this is by using long division, and I won't rehash all the steps here, but you can go through and verify that all of this is correct. But there is a much quicker way to get the answer by using a process called synthetic division. Now, to set up a synthetic division problem, the first thing to notice is that when dividing by x minus 3, we're going to represent that with a positive 3 over here. And then the coefficients of your dividend here, which are 2, negative 7, 0, and 5, those are all written down here. And then now the process begins. And the process is essentially this. The first number here is going to come down, and then we're going to multiply 3 times 2, which is 6, and then we add these numbers. Negative 7 plus 6 is negative 1. And then repeat. 3 times negative 1 is negative 3. 0 plus negative 3 is negative 3. 3 times negative 3 is negative 9. And 5 plus negative 9 is negative 4. And you'll notice that the numbers that you get here match up perfectly with the answer that you see here and here. In other words, the coefficients of your answer here are 2, negative 1, and negative 3. And you should notice those numbers right there. And your remainder is negative 4, which is the final number that you get here. Now let's go through a new problem. So this example is the problem that we just looked at, but we're going to take it from scratch. So when I'm using synthetic division to divide a polynomial, first let's start with the dividend, the polynomial that we're dividing. We have 2x cubed, negative 7x squared, 0x, it's very important you remember to put the 0 in, and then positive 5. And notice that I'm only writing down the coefficients. And then what I like to do here is just make a little box, and this box is going to represent what we're dividing by, which is x minus 3, but we're going to put a positive 3 in the box. So you always have to remember to put the opposite of the number that you see here. Now, the reason you do the opposite is so that when you do the division process itself, you don't have to subtract, you can add instead. But I wouldn't worry about too much about why this works. I would just learn how to do it. Okay, the first step now in the actual division is we're going to bring the number 2 down here, and then we multiply. 3 times 2 is 6. We put that answer here, and then we add these two numbers together, which gives us negative 1. And then we multiply again. 3 times negative 1 is negative 3. When you add those together, you get negative 3. And finally, 3 times negative 3 is negative 9. And when we add these together, we get negative 4. And I like to put negative 4 in the box. This is our remainder. And now in terms of writing the answer, it all depends on how they ask for it. But typically what we're going to do is say 2x cubed minus 7x squared plus 5, when divided by x minus 3, gives us an answer, which is right here. Now that answer represents 2x squared minus 1x minus 3, and then plus the remainder, which is negative 4, and that goes over our divisor, which was x minus 3. Now, one final note here is when you're writing your answer, you don't have to put the negative 1 in front of the x. You can just write negative x. And when you add a negative here, you could just change that to subtraction and then 4 over x minus 3. But once you get used to synthetic division, it's a much simpler process than long division. Now, one quick note about synthetic division is we can only use synthetic division when dividing by very simple linear factors. So notice that I'm dividing by x minus 3. And in general, synthetic division only works when dividing by x minus some number or x plus some number. Next, we have something called the remainder theorem. The remainder theorem says if a polynomial p of x is divided by x minus c, then the remainder is p of c. And in the next example, we want to use the remainder theorem to find the value of a polynomial. So here we have our p of x, and we want to find the quotient and remainder when p of x is divided by x plus 2. So let's use synthetic division to do this part. So I have my main polynomial, which is 3x to the fifth plus 5x to the fourth minus 4x cubed. Now notice that there is no x squared here, so we're going to put 0x squared, positive 7x, and positive 3. And we're dividing by x plus 2, so we're going to put a negative 2 in the box. First step is bring down the first number, and now we're ready to divide. So synthetic division process says we multiply negative 2 times 3, which is negative 6, and then we add 5 plus negative 6 is negative 1. Next, negative 2 times negative 1 is positive 2. And then we add negative 4 plus 2 is negative 2. Negative 2 times negative 2 is positive 4. 0 plus 4 is 4. Negative 2 times 4 is negative 8. 7 plus negative 8 is negative 1. And finally, negative 2 times negative 1 is positive 2. And 3 plus 2 is 5. So the quotient when dividing is this part right here. Now, what does that represent? There's a lot of numbers there. Keep in mind, you divided a 5th degree polynomial by a 1st degree polynomial. So this is going to be of a degree that is 1 less than what you divided by, or what you divided rather. So this represents 3x to the fourth. And then from there, it's simply negative 1x cubed, negative 2x squared, positive 4x, and negative 1. That's your quotient. And the remainder is, of course, positive 5. That's just this number here. Now it says use the remainder theorem to find p of negative 2. Now this is kind of a trick question. We don't actually have to do any additional work to find p of negative 2 because the remainder theorem says when you divide a polynomial p of x by x minus c, the remainder when you do that is the value of p of c. So if you are dividing by x minus negative 2, for example, which of course is just x plus 2, then this is going to give you a remainder that is equal to p of negative 2. So if I want to know what is p of negative 2, all I have to do is look at the remainder here, which of course is 5. Now this might seem magical, but you can actually compute p of negative 2 by using the original polynomial, right? So you can just plug negative 2 into here. But notice that this is a lot of work. So if you plug in negative 2, you're going to get 3 times negative 2 to the 5th power, plus 5 times negative 2 to the 4th power, minus 4 times negative 2 to the 3rd power, plus 7 times negative 2, plus 3. Now if we do the math here, we're going to have 3 times negative 2 to the 5th power is negative 32, plus 5 times negative 2 to the 4th power is positive 16, minus 4 times negative 2 to the 3rd power is negative 8, plus 7 times negative 2 plus 3. Now let's do the multiplication. 3 times negative 32, 5 times 16, negative 4 times negative 8, 7 times negative 2, and positive 3. And now if you add this up, negative 96 plus 80 is negative 16. Negative 16 plus 32 is positive 16. 16 minus 14 is 2, and 2 plus 3 is 5. So I hope this makes you believe that indeed the remainder that you have here is equal to the function value p of negative 2. Now, why is this useful? Well, because when you get used to this, the synthetic division process is much easier than doing this work here. Next, let's talk about the factor theorem. The factor theorem states that the number c is a zero of the polynomial p if and only if x minus c is a factor of p. So for example, if our polynomial p of x is x cubed minus 7x plus 6, first let's show that p of 1 is equal to 0, and then use this fact to factor p of x completely. All right, so first of all, how do I show that p of 1 is equal to 0? Well, one way to show it is just to plug in the number 1. So that would be 1 cubed minus 7 times 1 plus 6. This is 1 minus 7 plus 6, and this indeed is 0. But I could have also shown that p of 1 equals 0 by using synthetic division. So I can just put the number 1 in the box, and then we have 1x cubed, 0x squared, negative 7x, and positive 6. And from here, I just use synthetic division. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1 again. And negative 7 plus 1 is negative 6. And 1 times negative 6 is negative 6. And 6 plus negative 6 is 0. So once again, we can see that p of 1 equals 0 by using the remainder theorem. Now here's the magical part. We now know that x minus 1 is a factor of the polynomial, because the factor theorem says if the number 1 is a 0, then x minus 1 is a factor. So what does this mean? Well, it means the original polynomial, which was x cubed minus 7x plus 6, can now be factored into x minus 1 multiplied by 1x squared plus 1x minus 6. Of course, I'm just getting that from right here. But this allows us to find the other zeros of the polynomial, because we know how to factor x squared plus x minus 6. We know that this is x plus 3 times x minus 2. So the other zeros, in addition to x equals 1, are going to be negative 3 and positive 2. And now I have all the zeros of the polynomial. So the factor theorem, along with synthetic division, means that we can use synthetic division to help us factor polynomials. And this is a huge advantage. Now in our final example, we want to go backwards. Let's find a polynomial of degree 4 that has zeros, negative 3, 0, 1, and 5. And also they say the coefficient of x cubed has to be negative 6. We'll worry about that later. So what does our polynomial p of x have to look like? Well, if negative 3 is a 0, that means that x plus 3 has to be a factor. And if 0 is a 0, that means x minus 0 has to be a factor. If 1 is a 0, that means x minus 1 is a factor. And if 5 is a 0, that means x minus 5 is a factor. So that means our polynomial has to be the product of those 4 factors. Now x minus 0 is just x, so I'll put that one first. And then we have x plus 3, x minus 1, and x minus 5. So now to find the polynomial p of x, I just need to multiply these out. So I'm going to start by multiplying just any 2 of these factors, and I'm just going to start by multiplying the last 2. So the first 2 factors, we'll leave those alone for now. And then we have x minus 1 times x minus 5. When you multiply that out, you're going to get x squared minus 6x plus 5. Now I'm just going to multiply the next polynomial. So we're going to have to multiply all of these things together. We'll leave the x out there for now. And we have x cubed minus 6x squared plus 5x plus 3x squared minus 18x plus 15. So double check my work here. Simplifying, we get x cubed minus 3x squared minus 13x plus 15. And now I just need to multiply x to all of these, and that's pretty simple to do. That's just going to be x to the fourth minus 3x cubed minus 13x squared plus 15x. And this is our polynomial p of x. However, they did say that they wanted the coefficient of x cubed to be -6. Notice that the coefficient of x cubed currently is -3. Well, what I can do to make that coefficient be -6 is just take that polynomial and multiply the whole thing by 2. Now, notice that when you multiply a polynomial by a constant, it does not change the factors of the polynomial. So you have the same zeros, but multiplying everything by 2 is going to give me the -6 that I want in this spot. So we have 2x to the fourth minus 6x cubed minus 26x squared plus 30x. And so this is the polynomial that has all the zeros that were stated in the beginning, but also has a coefficient of -6 in front of x cubed. And here's what the graph of this polynomial would look like. And I want you to notice that it has x-intercepts -3, 0, 1, and +5, just as they mentioned in the beginning. And that concludes this video lesson.